Example 5, the population of foxes on the outskirts of a city is starting to increase. Data collected suggests that a model for the number of foxes is given by where n is the number of foxes t years after observations begin. Explain why this model does not predict that the population of foxes will grow to 6,000. Now, tech-free, let's just think about graphing. So if I look at the exponential here, so if I had, I'm going to write it the other way around, negative 320 e to the negative 0.3t, and then I'm going to put the plus 480. Now, the negative out the front means a reflection on the x-axis. The negative in the power means a reflection on the y-axis. And then that 480 is a vertical translation. Okay, so let's think about this. This basic graph here, without that vertical translation. There's my basic graph. I've reflected in the x-axis, and then I reflect in the y-axis. All right, and then I have to move the whole thing up 480. So let's make the graph red. That's our orientation of our final graph. And then that moves up 480. So what you should see is that if I had n of t equals negative 320 e to the negative 0.3t, my asymptote would be y equals 0. If I then add 480, the vertical translation up 480 units means my asymptote becomes y equals 480, or in this case, n of t equals 480. That there is the maximum population. $480 is less than 600, therefore population cannot reach 600 foxes. Now, if this was a tech active question, let's go and graph. So let's enter our function. 480 minus 320 e to the negative 0.3x. Now it's asking us whether the population will grow to 600, so let's graph that. Tab 600. Now if I go menu, window, zoom, zoom fit, you can see that it's putting in that information that I want. And you can see that asymptote. Now I'm going to zoom in a little bit more. Menu, window, zoom, window settings. Let's make our y min 0 and our y max be that 600. Well, let's go 650. And you can see that a little bit better. If I put that 480, which is the asymptote, you can see that there.